and the fox and the bear and the squirrel are in a canoe or a boat, a rowboat. Okay, good Friday morning. Welcome, welcome back to the Backyard Naturalist, which is hosted by the Urban Ecology Center. My name is Tim, and I will be the host for today's episode. And I'm taking a slightly different approach, not so much focusing on a particular organism or a concept, but now that we are solidly in the middle of a winter season, we're going to look at about, I don't know, a dozen or so different species slash adaptations, and to look at how life adapts to living in cold environments in the winter. For those animals that are in the far, mainly northern latitudes, based on how land on our planet is, there's not so much the southern equivalent of the Arctic region. There's some places, obviously Antarctica. So animals that are usually mainly in the far north, and how they deal with the challenges that are posed in the winter specifically. So primarily this, you're talking about a huge reduction in available energy because the temperatures drop. And for a lot of animals, staying alive is their goal in the winter. And so all of a sudden there's this huge reduction in food or fuel or ambient temperatures that help you maintain homeostasis. And the adaptations are grouped into three major strategies, particularly for animals and animals in cold climates. So one strategy is you can escape the cold conditions by leaving, by migrating, just getting the heck out of there. Another strategy is to basically hunker down and remove yourself as best you can from the ambient surrounding conditions, so hibernation. And we'll see hibernation is really more of a spectrum. And then the final strategy is to just face the winter conditions head on and stay active. And for a lot of the time that I was putting together this particular slideshow, it was dark because it gets dark so early. And every once in a while, I'd kind of peer out my window and just think about all of the life that is alive outside of my house they're facing the conditions that I can mostly escape from inside my house. And granted, there is a whole community of animals inside my house that are taking advantage of the shelter that I enjoy, but there's a whole lot going on outside, and we don't tend to see it very well. A lot of it's happening in the hidden world. And that life is not just surviving, it's thriving. So hopefully you're watching this from a warm shelter, and I encourage you to relax the best you can in front of your device, grab a warm beverage, and we will jump into some stories told by the life outside in our backyards in episode 18 of season 6 of the Backyard Naturalist, Winter's Home. First, a warm message of gratitude for the subscriber community. We really appreciate your support. There are several levels of subscriptions, from seasonal to annual to super. And with your super subscription, you are automatically registered for our new series, Green Spaces, Familiar Faces, where local personalities take you on tours of their favorite green spaces around Milwaukee. Our first official field trip of this new format will take place tomorrow, this Saturday, and we will have community member and legend Miran Songara, who will take us on a short stroll through one of his favorite green spaces, and one familiar to many of us, which is Riverside Park. You can register for these trips individually, but you will save a bundle if you sign up for a package, and super subscribers are already signed up. So for more information on this, please don't hesitate to contact me or any member of the Urban Ecology Center's research team. And by signing up, in addition to getting these great programs, you are supporting the Urban Ecology Center. I'm also excited to announce next Friday, January 17th, Backyard Naturalist has kind of started a tradition of annual shorts episodes. So instead of one long program, we will have several shorts on different topics. I encourage anybody listening, if you'd like to try your hand at presenting and maybe a less I don't know, stressful environment, you don't have to come up with a long topic and have the whole thing. If there's something you want to talk about, 5 minutes or less, let me know. We'd love to include you. Each presentation will be around 5 minutes long, and this is actually also a good way to kind of get outside of the traditional things that we talk about in Backyard Naturalist, stepping outside of the box and sustainability and environment ecology. So if there is something that you think about and you'd like others to think about, please let me know and we'll put you in for a very short presentation. And then another thing about today's episode is it's a little bit of a sneak peek into our upcoming winter ecology class that will be taught at the newly renovated Washington Park Urban Ecology Center. For a good part of the year, at least traditionally, Milwaukee's green spaces go through an extended period of cold that often involves snow and ice. So for wildlife, plants, and other forms of life, this poses challenges we're going to look at today, and those challenges require adaptive solutions. We will explore what we know and what we don't know about how organisms, mainly urban organisms, survive and thrive in the cold, and then how they interact with other organisms and the physical environment. So we'd love to have you along for this journey of learning. It's in-person, college level material without the homework. You can register on the Urban Ecology Center website. And if you have any questions, please don't hesitate to contact me. Also, if financial systems are a barrier, please let me know. We'll keep it very discreet and we'll see what we can do to get you into the course too. So as I mentioned, it is solidly winter. So whether you go by the meteorological calendar or the astronomical calendar, we are in winter right now. It's been pretty cold outside. We haven't gotten as much snow as I'd have liked. We've had a little stops and starts. I've done a little bit of shoveling, but there are challenges in any environment, whether you're in a tropical paradise, rainforest, whether it's a seasonally dry area, or an area like ours where conditions are constantly changing. The biggest challenges that winter poses are mostly due to temperature, but then also water and food availability. So when temperatures drop and you are a warm-blooded animal, it takes more and more energy to keep your body warm, to keep it at the level that you need to. If you're a cold-blooded animal, you have much less control over that, and you have to figure out a way to let your body's drop in temperature in ways that don't kill you. So in regards to water, you might have a snowy field that okay, there's plenty of water here, but just like if you're in the middle of the ocean, water is everywhere, but you might not be available to you in that form. So in some ways, winter can be like a desert for certain organisms. For other organisms, you may have to deal with water freezing inside your bodies because you can't maintain an environment that's warm. And then again, for others, you just need to disappear. If you're an insectivore and you can't switch diets, it's going to be hard for you to find insects in February. If you're a carnivore and you eat other animals, then there's more of a chance for you to maintain your diet through the winter. A lot of challenges, and the goal today is to point out how some animals are able to cope with these challenges through adaptations. So, started here. This is an easily recognizable bird, mainly because of Harry Potter, but the snowy owl, most people know what a snowy owl is. And the snowy owl, or can identify a snowy owl. Snowy owl is basically looking winter straight in the eye and said, bring it. There's a whole group of northern owls that are superbly adapted for the conditions of winter, starting with downy feathers, a big system of feathers that provide insulation, all the way down to their toes. So if you see a bird, like a rough-legged hawk, if you see, or any mammal, but mainly birds, let's say we'll start with feathers, and the feathers are everywhere. They don't have, bare patches on their legs or things like that. It's probably a bird that's adapted to cold conditions. Birds are also warm-blooded. but they have to maintain a higher body temperature than most mammals. So we maintain homeostasis at about 98 degrees. I hear that it's maybe that number's dropping a little bit from an evolutionary perspective, but most birds need to maintain an internal body temperature decently higher than that, often around 104 degrees. So from an insulation standpoint, they're already a disadvantage because they have to maintain a much higher body temperature than we do. So that is one of the reasons that snowy owls and great gray owls are superbly insulated. In fact, all those feathers make, for the snowy owl in particular, that is the heaviest owl in North America. A 4-pound owl is heavy. It's about a pound more than the great horned owl. And for a bird that has to fly, that's a lot of body weight. And they're white. A lot of animals that are here in the winter either change to white coloration or are white or have a color white. White is good for camouflage in the snow, not so good for absorbing heat. And snowy owl, you see actually quite a bit of white and dark speckles based on their age and sex. If there is a big snowpack, one might worry that it makes it harder for them to hunt their favorite food, mainly small rodents, particularly lemmings, one of their all-time favorites. But for the snowy owl and for a lot of owls in particular, they don't need to be able to see their prey to catch them. So they have their finely tuned offset ears that allow them to pinpoint prey under the snow without seeing them. They can triangulate. It's a miracle system. I mean, it's just so intricate how they're able to pinpoint sounds. And so you will see videos of owls, snowy owls, great gray owls, barred owls that are basically plunging into what looks like snow, bare snow, and then you see them plunge feet first and emerge with their prey. So nobody except for the owl and the lemming knew that the lemming was there. So that is an adaptation to snow, which can, for some, can bury their prey. And then after something like that happens, you see these cool feather snow angels after the hunt. But another problem, particularly for snowy owls, is that their prey, the lemming, is not stable at all. And lemmings are well known for going through population cycles, population crashes and booms. So in some years, there are more than enough lemmings to go around, and when that happens, there's enough lemmings to maintain the population of snowy owls in the north. It is not as simple as I'm saying this. There's more factors at play, but when the lemming population is high, the snowy owls can kind of stay where they are. When the lemming population crashes through their mass suicide, which is not true at all. This does not happen. This is a myth, a very dark myth that was started by Disney filmmakers who, for good footage, show this dramatic scene. I think it's like the Wonderful World of Disney Wildlife something or other. I remember seeing it. You have all these lemmings that are falling, look like they're jumping off a cliff, and it was caged as this is a way for lemmings to control their population. They're they understand that their populations are too big, so they kind of go through this self, uh, well, I don't know what you call it, but this control. They say, okay, we're too big. We're gonna just, for the good of the species, we're gonna all kill ourselves. If you look really closely at the footage, you can actually see hands of people, and they're literally throwing them off of the cliff for good footage. It makes a good story, but it's not true at all. But there are reasons that lemmings undergo these huge cycles, predator-prey relationships, and so when the lemming populations crash, then the owls, again, I'm simplifying a little bit, the owls need to spread out because there's not enough food to maintain in the breeding area. And so when this happens, the snowy owls in particular will undergo what we call an eruption, and they will fly away from their breeding grounds, sometimes very far away. So this is an eBird map that shows snowy owl sightings. This was just a few years ago, and you had a snowy owl in Mississippi and Florida and even Bermuda. And so these eruptions are wonderful for bird watchers, but it's hard on the snowy owl population. Typically, it's the younger birds that migrate. And if you think about it from their perspective, they could either stay on the breeding grounds and compete with more experienced birds and probably not get enough food, or they can leave the breeding grounds, which are less ideal hunting grounds, but still you're probably going to get enough food. And this is also dangerous. So it's good for food, but it can be dangerous because um, snowy owls in particular do not, well, there's a lot of dangers in migration in general, but in particular, these eruptions will bring owls to areas with humans. Humans tend to be in greater concentration in areas away from these barren Arctic landscapes. And um, these owls have evolved in the absence of humans, and so they are diurnal hunting birds in general. In the summertime, they're almost hunting constantly. And they, when they're hunting, they tend to fly low. And this makes them very vulnerable to being hit by cars because in breeding grounds, there's no cars, there's hardly any roads. And they're not used to paying attention to these large speeding metal objects. The Urban Ecology Center has a beautiful snowy owl mount that was donated by Noel Cutright a while ago that was unfortunately hit by a car. So these young birds, again, they're either faced with staying in the breeding grounds, risking starvation, or erupting south to places like Milwaukee, where they will likely find enough food, fewer owls, but again, they're faced with the dangers of migration and being in a new, unfamiliar territory. So they're just quickly, snowy owls are represented in cave paintings that are tens of thousands of years old. So it's not just Harry Potter. Humans have been captivated with snowy owls for a very, very long time. Moving on to another bird, a bird that is closely related to the partridge, which we featured a few weeks ago, the ptarmigan. And you, at a glance, you see the ptarmigan and the snowy owl have very similar strategies for dealing with a cold, snowy environment. Lots of well-insulated feather layers. The feathers go down all the way to their toes. In fact, the Latin name is lagopus, which means hare-footed in Greek. The white color is really good camouflage in the snow, but unlike the owl, the ptarmigan in the summer undergoes a dramatic molt. And you see this with a lot of birds and other animals that tend to be prey items. So the snowy owl can afford to stay whitish all year. There's not a lot that's hunting them. If they stick out, obviously they don't want to be seen by their prey, but they can sneak up on their prey. But if you're a prey item, then being white in the middle of summer could be pretty hazardous. So you see this with a lot of mammals and birds that they'll change color from white to winter, from white in the winter to darker in the summer, and that's an adaptive strategy for the snow. Another adaptation that ptarmigans use when weather gets really cold, and we talked about this a little bit in the partridge episode too, is that they will just plunge their bodies headfirst into deep snowbanks as night comes. So they basically plunge into a snowbank and they create a nice little sealed off snow cave that they can use for sleeping through the really cold conditions of night. And a combination of their body heat, snow has great insulative properties. So they create these little snow caves that can be sometimes 25 degrees warmer than the nighttime air outside. And in the morning, when they're ready to go out, once the sun is out, warming things up again, they'll just burst out of their little snow caves, often scaring the heck out of anybody that's walking by. Quick cool fact about the ptarmigan is it comes from the Gaelic word tarmashen, but which starts with a T, and then the silent P that came later was added by early ornithologists thinking that the word was Greek. They said, hey, if this is a Greek word, we have to add a P in front of it, like pterodactyl. So that's why that's why ptarmigans don't start with a T, even though initially, and they probably should based on their word origin. But it makes it fun when you do ABC songs, O is for owl, P is for ptarmigan. And before we move away from birds, it is worth noting another remarkable adaptation to cold wintry conditions, and you see this in waterfowl and gulls. You will see birds standing on ice for long periods of time, and the question that comes to mind easily is why aren't they freezing? Why don't their feet freeze to the ice? And how can they have bare skin on the ice? They don't have that nice feathery layer on their feet like you see with the owl or the ptarmigan or other birds. It's just straight up bare skin on straight up frozen water. So the adaptation that allows them to do this, or one of the main adaptation that allows us to do this, is called countercurrent circulation. Basically, in the legs, you have, it's almost as if it were engineered to be this way, but the arteries and veins run not only parallel to each other, but very close to each other, almost butting right up and next to each other. So that allows for heat exchange all within that system. So warm blood that's leaving the body down the legs is going to lose heat very quickly in a cold environment. To normally that would just go to the surroundings. But if you make the surroundings the veins, then you're losing heat from the arteries to the veins. The veins are absorbing that heat, and then the veins are warmed up. Normally they'd bring cold blood back to the body, but now the blood is warming up by the arteries so that the blood returning to the body isn't freezing cold and is almost the same temperature as it was when it left. So again, like you couldn't design this better. It's a remarkably efficient system, and you can see how remarkably efficient this is on that little graph on the right. You know, blood leaving the body has cooled slightly to about 30 or 95 Fahrenheit, and then gets really, really cold down in the capillaries, almost to freezing, just above freezing, 33, 34 degrees Fahrenheit. But then by the time that really cold blood returns to the body, that heat exchange system brings the temperature to almost the same as it was when it left. So 33, 90, 30, 92 degrees Fahrenheit. So you've lost a few degrees. So despite reaching levels close to freezing, you're only losing a few degrees total. Again, a really, really cool system. A lot of our birds, however, are true snowbirds, meaning they're getting just get the heck away from here before the snow hits. Either they don't have the adaptations to the cold, the food is going to be a problem for them. Bird migration is epic. It's amazing. A lot of stories in that arena that we've gotten into in the past and will again in the future. This particular bird is one of the record holders. We usually the go-to bird is the Arctic tern in terms of migration, but the bar-tailed godwit, there was a tagged individual, a satellite tag, that flew 8,500 miles without stopping on a single flight. So bird migration, you can get away from here pretty quickly. Why are you going to stick around in these cold conditions? So from birds, we move to another very familiar group, the mammals. And we'll start with a look at two of our most familiar backyard mammals. So you have the eastern chipmunk and the gray squirrel, fairly closely related to each other. The gray squirrel is considered a tree squirrel, and the chipmunk is considered a ground squirrel. Similar niches, but they handle winter in very different ways. I feel like the snowy owl, squirrels are just like, okay, winter, let's bring it. I'm ready for you. But maybe they're a little more deferential because they do quite a bit of preparation before winter arrives. And if you watch your backyard squirrels, particularly in the fall, you'll probably see one of these preparations in action, which is finding and burying and caching food. So squirrels spend a good amount of time in the fall burying acorns and other nuts and seeds. A lot of times they're burying food in the ground. They'll also hide them in tree cavities or crevices. I remember watching a squirrel from my front porch one time, and it was going to a neighbor's squirrel feeder that had peanuts, and it was grabbing the peanuts and then going to different houses in the neighborhood and burying them. And at some point, it came to my house, and it buried one of those peanuts in a planter that we had on our front porch. And I was reminded of that the following year because next spring a peanut plant grew out of the planter. So I knew who planted that peanut because I saw it. So this process of burying and hiding food for the winter is called caching, sometimes hoarding. And squirrels in particular, these gray squirrels, cache food in a style that's known as scatter hoarding. So there's all kinds of studies that look at different kinds of caching and all of the different processes. So scatter hoarding means you're burying many, many, many nuts in many different locations, usually single one-off. So bury a spot, dig a spot, put a peanut in, bury it, or an acorn, go to another spot. So this gives them a steady supply of food later in the winter. It's obviously available to anybody that can find it, but there's a lot of research around how acute their memory is to find buried food later. There's, some that argue, say it's more random, some that say it's more intentional. But regardless, they don't find it all. And so if they are burying acorns and they forget a few, then that acorn is in perfect position to become a new oak tree, or in my case, the peanut plant. So the squirrels are providing a good ecological community service to the plants that provide them the seeds for sustenance. So the squirrels are in it for the winter, remaining active. They do need to sleep in sometimes very cold conditions. So they often build a nest called a dray. At a glance, they look like bird nests, but you can usually tell them apart from bird nests because they appear much more haphazard, a lot more kind of just dead leaves around, not as orderly. And essentially, it's making a nice little roost and for sleeping. The leaves bunched together provide insulation. So when the squirrel is in the dray, its body heat is getting trapped in these nice little air pockets. So it's like having their own little down comforter, keeping the temperature inside the dray warmer than the surrounding areas. They're not always in tree branches. Sometimes they're in cavities or hollows. And if it's a really cold spell, they will hunker down in that dray maybe for a couple days, but eventually they need to go down to the freezer and get some of their food. There are other adaptations in squirrels. They have a nice, thick, multi-layer coat of fur. They can fluff up that fur for extra warmth. They can use that tail as kind of another blanket to curl up. They do add a nice layer of fat reserves that they can tap into. They tend to, I mean, that's kind of more of a contingency fund. And they also engage in group cuddling, particularly younger squirrels who will pile in a nest together to conserve body heat. So in a nutshell, that's the squirrels. Chipmunks in the fall, at least at the start, will behave similarly to the gray squirrels. So they're running around hoarding nuts in their expando cheeks for burial, but they're not running around burying these one by one across your lawn. The chipmunks are taking their nuts to a single destination for their winter fuel, which is their home, their burrow system. And so they'll have, I don't know, in my opinion, this is a much more sensible way of dealing with the winter. So at some point, the chipmunks say, in winter, they're like, I'm out. You don't see them. They turn off the lights, they hunker down in their little hygge chamber, which is why you don't see chipmunks in the winter like you do see gray squirrels. In fact, the Urban Ecology Center staff have a little friendly competition to see who can observe the first gray squirrel popping out of hibernation in the spring. And I say the word hibernation loosely. So these nerdy scientists argue quite a bit about what true hibernation is, whether individuals are true hibernators or not. To me, the words are less important than the understanding that there is a big spectrum of behaviors that animals use. And squirrels are very much toward, or chipmunks are very much toward the hibernation end of the spectrum. So they go through extended periods where their body temperatures drop considerably, their respiratory systems slow way down. A lot of people equate this with sleeping, and sleeping is often the first step towards hibernating, but recent evidence is showing that this period is not the same as what we would consider true sleep. You look at this and you think, oh, that is so comfy cozy. And who knows what the squirrel is, the chipmunk's feeling. But it might not be as peaceful and relaxing from a body physiology standpoint. It's harder on the body systems than if they were in true sleep. So the sleep patterns that are really beneficial to us mainly happen at when we're in homeostasis. So to go into this period, it's not great on the body. It's not like it's like a spa or anything like that. It's harder on the body to be in this. It's not the range that the body wants to be in. So there are periods of sleep. They do need to sleep to survive. And sleep does happen, but it happens during periods that, uh, again, a lot of when you think of hibernation, okay, they're asleep and then they're awake. But most hibernators are waking up quite often. It's not asleep through the winter. They're waking up quite often. And during those times when their temperatures come back to wake, they do go through periods of that kind of restorative sleep. But their burrow is a lot of seeds. There are also fruits and vegetative sustenance mixed in there. John James Audubon did a basically took apart a single chipmunk burrow and found, according to his study, 8 quarts of acorns, 2 quarts of unmixed buckwheat seed, a quart of hazelnuts, and a half cup of mixed wheat and buckwheat seeds. And for those of you not familiar with the modern measurement system, a half cup is about a gill. So the chipmunks do not have the body reserves, fat reserves, to allow them to sleep through the winter. So they have to wake up and go snack and then come back and go back into hibernation. So it's not this long restful period. There's these periods of actively um, body temperature going back up and waking up. And even hibernators that don't have to wake up to feed, because a bear is big enough to rely on its body fat, and it wouldn't make sense for a bear to have little stores of food in their dens. So even bears, their body temperatures rise and fall at a regular uh, uh, irregular pattern during the summer. So again, part of that is the body needs to enter that homeostasis range for certain functions. So black bears, which are also local, are also hibernators. And instead of having little stashes of food, they're relying on their body fat to get them through the winter. And as a trend, you'll see this, the smaller hibernators mostly rely on cached food, like the chipmunk, because there's no way a chipmunk can put enough body fat on that tiny body to make that an effective strategy. The larger the hibernator, the more likely they are to rely more on body fat. And animals do both. Like the chipmunks will still put on some body fat. But regardless of what they do, all hibernators go through those periods, the cycles of body temperatures rising and falling. In fact, if you look at the body temperatures of most hibernators, it goes through, you see these cycles. So it's not just cold in fall, wake up warm in spring. So this is the graph of the body temperature over time, over the course of a year. Post and pre-hibernation, the variation is small. They're in that homeostasis range. And you see that huge drop at the start of hibernation. And then on a very regular basis, body temperatures return to normal. Lots of either waking up to feed or just the body temperature coming up even though the animal like the bear might not be moving around. And that's for functioning. So we'll get into this a lot more in the winter ecology course if this is something that nerds you out. And before we move on from mammals, just a quick look at a couple of trends. So another way for a mammal to adapt to winter conditions is just to be bigger. Body heat is lost through the skin, and an important component of how quickly body heat is lost is related to the ratio of the surface area to the volume. So a larger animal has a much lower surface area to volume ratio, or you could think of it as a skin to body volume ratio. With a less skin to body, there's less opportunity for the heat to leave and more opportunity to retain that heat in the body, whether it's through the feathers or fur or the internal systems. And this leads to a pattern that we call Bergmann's rule, which states that within a group of animals, those that live in colder environments tend to be larger, and those in smaller environments tend to be smaller. So you see that the obvious cases in bears, the polar bears, the grizzly bears tend to live in the far north. Black bears, spectacle bears, sun bears, tropical bears tend to be much smaller. And even within a species, so polar bears are the biggest bears, but even like black bears have a wide range. Black bears tend to be bigger in the north and smaller in the south. You see this in rabbits, the, the, the larger hares in the north, much bigger, meatier, smaller rabbits you tend to find in the tropics. And you see this in deer. The biggest deer, the moose, the elk, they're in the north, little brocket deer in the south. And just like with the black bears, white-tailed deer have a very wide range, but the white-tailed deer in the north tend to be much bigger than the white-tailed deer you find in the tropics. And then before we move away from mammals, since birds and mammals hog the majority of these examples, you can ask the question, why do so many birds migrate, but so few mammals are migrating? And like everything, it's a complex answer. There's a lot of factors at play, but probably one of the biggest ones is flight. Even though it's very energetically demanding, through flight, a bird can fly great distances in a metabolically efficient manner. For animals to go great distances in any, you know, without spending a long, long, long time doing it, it would be much less efficient. So if they're walking, it would be so slow. If they're running, it would be very energetically inefficient. In fact, in most cases, a mammal expends about 10 times the energy of a bird of equal weight to move the same distance, which leads us to the exceptions. Bats fly, and bats also tend to migrate. A lot of them do migrate. You see, it's much more common in bats. Whales don't fly, but they fly through the water, and so swimming is much more energetically efficient. So you do have these very long distance migrations in mammals. And you also see an exception that there are some land mammals that undergo vast migrations, whether it's a caribou or the African plains. And that's a complex story in its own right. In the case of the caribou, it's affected more by food and biting insects. But with few exceptions, mammal migration is much less common than bird migration to escape winter conditions. I am totally guilty of dominating today's stories with mammals and birds. I promise in the winter ecology course this won't be the case, but we will mention a few of these other groups. So winter poses a completely different challenge for cold-blooded animals, or poikilotherms, who have very little control over their internal body temperature. So when it gets cold, their metabolism slows to the point where they become almost completely helpless. And so for the vast majority of these organisms, hibernation is the only means of surviving the winter. And you see this in the fall too, with bees. Early morning, bees will be just sitting on the flower, just waiting for that sun to wake them up and allow them to move. But other than that, they pretty much have to just stay there. So as days become shorter in the fall, reptiles and amphibians and insects go basically, they also have some physiological preparations, but they're essentially making their way to their safe winter hiding places. This could be under a decaying log, it could be deep in a rock crevice, it could be in the burrows of other animals. Snakes will do that. Snakes will even congregate in mixed species groups in rock dens. Frogs and toads may dig underground burrows in soft soil with their hind feet. I don't typically think of frogs as digging, but it's kind of fun to picture a frog digging a tunnel a couple feet down in the soft soil. More commonly, these animals will overwinter in the water. They'll either burrow into stream banks or lake bottoms, anything they can do to avoid having their bodies freeze, and that's the main game. Obviously, you don't want to die. And For cold-blooded underwater animals, there's a variety of adaptations or behaviors. So turtles and frogs can exchange oxygen in the water through their skin. They don't need to use their lungs. So sometimes they'll purposely seek out environments where the oxygen in the water remains high. I know turtle oxygen exchange can happen in the mouth parts. Um, there are also physiological adaptations that allow for respiration in an anaerobic environment. Tadpoles and insect larvae retain gills for oxygen exchange. And within these animals, some just hunker down in a type of hibernation. And the hibernation in reptiles and amphibians is called brumation. But some, like in the mammals and birds, some also just stay relatively active throughout the winter, which is why when you're ice skating, sometimes you will see turtle movement, fish movement under the ice. Hopefully it's not too thin, but a lot of different strategies. Plants don't have the luxury of hiding, and with water as part of their body, they're faced with the very real danger of ice freezing and destroying their cells. Some amphibians allow themselves to basically are exposed to freezing temperatures, and unrelated groups, but you will see similar adaptive mechanisms. So chemicals that act like antifreeze, processes that move water out of the cells into the spaces between the cells. So if they do freeze, it doesn't destroy tissue. Um, Plants have adaptations of moving materials underground. Essentially, getting underground and not too far underground really increases the chances that you won't be in a freezing environment. So it doesn't take a lot to get out of a freezing air temperature. And again, snow will provide that. Um, Leaf litter, soil, you often don't have to go far, but obviously the farther you go, the the better chance you have of survival, because you can prepare enough, but if your body does freeze for some animals, that will be the end, that you don't get out of that. So it is a little bit of a risky trade-off, as are all adaptations. And of course, for us, we get to see the beautiful fall adaptation of trees changing their leaf color in the winter. And I was wondering if animals notice the color change in leaves. Like, is that, I'm sure that people have studied this. I just was thinking about this. Like, is that a cue for animals? Do animals notice the change of green from green to yellow or orange? Somebody might know the answer to this. Is it even on their radar? Does it cue actions? Is there a stopping to marvel like we do? Who knows? Somebody might. It was my intention today to kind of go through a long list of examples of how organisms survive winter. So I kind of did that, but I was hoping to spread the love a little bit more among the groups. I didn't do that as well. Didn't mention fungi or bacteria or microscopic, but it's such a cool topic in my opinion, and I'm really excited to plunge deeper into these snowy stories of how life survives the winter, in the winter ecology class. So again, it's a 4-week course at the newly renovated, very comfy, I'm sure, Washington Park Urban Ecology Center. In the library, we'll be surrounded by the books of Noel Cutright. You'll be able to slide down to the first floor after class in the indoor slide. I'm really looking forward to it. I hope you'll join me for the class. And thank you for joining me today. Oh, I would just mention really quickly that in the course we will also talk about climate change, right? Your classic texts of winter look on classic winters, right? But now the winters are anything but classic. And there's a lot of threats to these long-term adaptations. Some animals and plants are going to be fine. They're going to be able to make the changes. Some are much more in trouble. And even if you think of that snowy owl, the lemming, the population crashes, the cycles of lemmings, one of the predictions is that the climate change is going to make those cycles much less. It's going to kind of smooth out the cycles, which is going to have some big effects on the animals that are adapted to those cycles. So a lot of ways that we can predict things will change. I'm sure there's a lot of ways that will change that we didn't predict, but it's our reality whether it's, you're noticing the changes in your lifetime because they are changing to you, and it's definitely going to affect the wildlife outside in our backyards. So thank you for joining me today. I will now stop sharing my screen.